So তাহলে এটা কি হলো? This is a float. Whenever the হ্যালো
হ্যালো স্যার, শোনা যাচ্ছিল না কিছু?
হ্যাঁ আমি ডিসকানেক্ট হয়ে গেছিলাম, এখন শোনা যাচ্ছে?
হ্যাঁ স্যার, শোনা যাচ্ছে।
আচ্ছা
হ্যাঁ স্যার।
ঠিক আছে, ওকে। দেখা যাচ্ছে স্ক্রিন?
হ্যাঁ স্যার, দেখা যাচ্ছে।
ওকে। সো তাহলে কি হলো, ফার্স্ট দেখো রোটামিটারে কি তাহলে কিভাবে কাজ হচ্ছে, হাউ ইট ওয়ার্কস। Gas will be flowing in this direction. Along with the gas, float also will be floating in a certain distance or in certain position. By the marking of outside, we can know the actual flow rate of that gas, in which flow rate gas is flowing through. That can be determined by this way. So this is the working of rotameter. This is known as rotameter. Another way of flow meter is there. This is known as soap bubble meter. This is the second one, soap bubble meter. This is far better than rotameter. How it works? It works through, suppose you see here, this is the gas inlet, gas is coming inside, there is a soap solution inside. এখানে একটা soap solution already prepared করে রাখা থাকে with a rubber bulb. There will be a rubber bulb, but it is like working somewhat like a valve. When the gas is coming inside, যখন first time enter করছে, it will make a pressure on the rubber bulb so that a bubble will be introduced inside this, in this graduated pipe, same like that previous one, আগের মতোই. So through a graduated pipe, these bubbles will be floating. So whenever the carrier gas will be flowing, these bubbles also will be floated up to certain distance, which can be observed from the outside. So instead of float, in this case we are using a soap bubble. So you can imagine how lighter, almost it don't have any weight. Float also how maybe little there, but this soap bubble will be a much lighter, almost negligible value. I think there is not at all any weight of that, because this is totally air, full of air. So the soap bubble will be changing its position as per the flow of the carrier gas, and through the graduated pipe outside it will be there, measurement will be written, so we can determine the flow of that carrier gas, how much speed or how much flow rate it is flowing. So we can regulate the flow through the flow regulator. So we are changing or we are controlling the flow rate by flow regulator. We are measuring or we are determining the flow of the carrier gas through flow meter. So these are the two type of flow meter we are using along with the gas chromatography instrument. So these two things, either that means flow regulator and flow meter, either of these one and two, either maybe rotameter or soap bubble meter. Generally in modern instrument we are using nowadays soap bubble meter. A rotameter is almost obsolete nowadays because of this much more sensitivity of this second one. This is also not a part of the instrument. This is also separate facility. It is kept hanging near the instrument. এটা কিন্তু সেপারেট একটা আলাদা জিনিস, যেটা কি হয় ইনস্ট্রুমেন্টের কাছেই কোথাও থাকে, রাখা থাকে, ওয়াল হ্যাঙ্গিং বলো বা কোনো একটা জায়গাতে ফিক্সড করা থাকে। এরপরে পাইপলাইন যেটা আসে গ্যাস সিলিন্ডার থেকে, থ্রু দিস টাইপ অফ ফ্লো মিটার ইট উইল এন্টার ইনসাইড দ্য ইনস্ট্রুমেন্ট, এরপরে ওই পাইপ লাইনটা ইনস্ট্রুমেন্টের মধ্যে এন্টার করে। সো carrier gas, neither carrier gas nor this flow regulator is the part of the instrument. বারবার এটা কিন্তু বলে রাখছি, মনে রাখবে এগুলো। So but still we are discussing, why we are discussing, without these two things we cannot operate instrument. এগুলো কিন্তু ইনস্ট্রুমেন্টের পার্ট নয়, ইনস্ট্রুমেন্টের বাইরে থাকে, they are separate facility, but still we are discussing because without these two things we cannot start gas chromatography operation, we cannot start starting the instrument. গ্যাসটাই যদি না থাকে, গ্যাস ফ্লো যদি না থাকে, ফ্লো মেজার করতে না পারি, we cannot start the instrument. Okay, so these are not part of the instrument, but still they are actively used in the operation of the instrument. This you have to keep in mind. So that same description is there, you see rotameter এখানে ওটাই description বলা রয়েছে, placed before column inlet having a ordinary glass tube. They are very simple instrument with a float held on spring. Level of float is determined by flow of gas. So by that flow of the gas only we can see the position, and from the position we can measure the flow rate. ওখানে গ্রাজুয়েটেড আগে থেকে মানে দাগ করা রয়েছে, কোন জায়গাতে ফ্লোরটা থাকলে কত ফ্লো রেট হবে, that is determined previously. So we can measure this. আর সোপ বাবল মিটার বললাম যে instead of float soap bubble is used, and ওই জাস্ট প্রসিডিউরটা এখানে বলা রয়েছে, that same description is there which I have discussed. Okay, so these two things is over. Number 3 is the sample injector. So sample injection system is very important is gas chromatography, as a small amount of sample is required for analysis. In case of HPLC or in case of gas chromatography, a very small or smallest amount of sample is enough for analysis. These instruments are very accurate and very sensitive. Sensitive in the sense, with a small amount of sample we can determine the type of the sample or the nature of the sample. So definitely 10 in case of HPLC also, you know, 10 to 20 microliter of sample is enough. In gas chromatography also same, 10 to 20 or maximum 50 microliter of sample is enough for the gas chromatographic analysis. So it should be capable of reproduce the sample and can vaporize immediately. So one condition of determining the sample in this instrument, I told, it is written, so the sample can be vaporized immediately, then only we can determine that sample through this instrument, otherwise we cannot determine that particular sample. So this is the injector. In case of gas chromatography also, generally we are using rheodyne or loop injector. Operation is same like HPLC instrument, same type of operation is there. এটা মনে আছে নাকি আবার বলতে হবে, ডেসক্রাইব করতে হবে? সেম
না স্যার
এইচপিএলসি তে
ডেসক্রাইব
যেমন
করতে হবে, মনে
বলেছিলাম
আছে।
লুপ ইনজেক্টর যেভাবে কাজ করে, এক্ষেত্রেও তাই একই ব্যাপার। বলো এটা কি আবার বলার দরকার আছে? লোড পজিশন, ইনজেক্ট পজিশন যেমন বলা
না স্যার
হয়েছিল,
বলা
স্যার
দরকার
মনে
নেই।
আছে।
মনে আছে তো? এটা তাহলে আর রিপিট
হ্যাঁ
করছি
স্যার।
না। সেম ওই লুপ চেঞ্জ হবে, একই জিনিস, এই জিনিসটা একই থাকে, শুধু ডিফারেন্সটা কি থাকে? ডিফারেন্সটা এটাই, ইনজেক্টরটা যখন আমরা যে সিরিঞ্জ নিডলটা যেটা ইন্ট্রোডিউস করি ইনস্ট্রুমেন্টের মধ্যে, এটা এইরকম ভাবে দেখো, এই ছবিটা থাকে, একটা সেপ্টাম থাকে, থ্রু দ্য সেপ্টাম নিডল এন্টার ইনসাইড দ্য ইনস্ট্রুমেন্ট সামহাট। এটা কি হয়, এর নিডলের লেন্থটা অনেক বেশি হয়। এইচপিএলসি ইনজেক্টরের ক্ষেত্রে যে নিডল যেটা দিয়ে আমরা ইনসার্ট করি স্যাম্পেলটা, তার থেকে এই নিডলের লেন্থ অনেক বেশি হয়, বিকজ দে আর এন্টার আপ টু দ্য ভেপোরাইজেশন চেম্বার। ইনজেক্টরটা যেখানে আসে শেষ হয়, সেখান থেকে ভেপোরাইজেশন চেম্বার স্টার্ট হয়, and after that immediately they mixed with the carrier gas and they come inside the instrument. So এখানে যেখানে তোমার স্যাম্পলটা, generally we introduce the liquid sample, so liquid sample is evaporated in a gaseous form inside the instrument with somewhat high temperature, then they mixed with the carrier gas and then they come inside the instrument, then they can be analyzed. So this is the only difference as compared to HPLC injector, but means actually the principle of operation or the construction of that injector is same like that type of rheodyne or loop injector in case of HPLC. So this is the description. Hypodermic syringe is used to introduce the liquid sample through the self-sealing rubber septum. Gaseous sample can be introduced by valve device into the column. Solid sample are dissolved in volatile liquid for introducing into the system, and loop injector or rheodyne injector is used to deliver the sample inside the instrument. So this is the one you have to remember along with this rheodyne injector or loop injector, how the sample is introduced by this type of needle through a rubber septum. Next part is the column. So as like HPLC also, this is a instrument. This also use column as a stationary phase. Okay, so after the injector or the carrier gas we have discussed, now we are discussing this part. Is this the column? That means which is the stationary phase of this instrument. Columns are generally made up of glass or metal tubing with internal diameter 4.8 mm. Ideally, that may vary also sometime, but in general, the diameter of this tubing is like that. So it may be a glass or metal tubing. Length of the column may vary from few centimeter to 100 meter. It may vary up to 100 meter. You can imagine. Remember, এটা কিন্তু মনে রাখবে. 100 meter means you can assume কতটা কল্পনা করতে পারছো 100 মিটার রেস হয় যতটা, তাহলে কালাম লেন্থটা কতটা হওয়ার কথা, ইনস্ট্রুমেন্টটা কতটা বড় হওয়ার কথা। বাট অ্যাকচুয়ালি the column is, if still it is 100 meter, but they are not kept in a length, লম্বায় রাখা হয় না, কিভাবে রাখা হয়, in a coiling. So column HPL, that gas chromatography column are kept in a coiling or tubing. যেমন ওই কারেন্টের তার পেঁচিয়ে রাখা হয়, একটা কয়েল করে একটা জায়গার মধ্যে লম্বা তার পেঁচানো থাকে, ঠিক সেই রকম ভাবে HPLC তোমার জিসি কালামটাকে ওইভাবে পেঁচিয়ে পেঁচিয়ে রাখা হয়। So by this way we can accommodate a very high length of column inside a single coiling. This is the column, this is the coiling of mobile phase in case of gas chromatography. So এই যে এরকম ভাবে পাকিয়ে পাকিয়ে রাখা হয়, গোল করে একটা জায়গাতে মধ্যে পেঁচিয়ে রাখা হয়, so that we can accommodate even up to 100 meter also in a length of a particular column. So you can imagine why I told beginning এ আমি কেন বলেছিলাম the extent of separation, quality of separation is much better than HPLC column. Reason is this: length of the column is much higher. Clear? So this can be this is the major point or the reason for which it can give much better results. আমরা কালাম যেটা থিওরিতে কি ডিসকাস করেছিলাম, রেড থিওরি and plate theory. If the column length is increased, extent of separation also increases. But case of HPLC, we cannot increase the column length much more because of the some problems. But in gas chromatography we can make it large. কেন ডিফারেন্সটা কেন? নেক্সট কোশ্চেন মেবি দেয়ার, স্যার কেন জিসি তে করতে পারছি এইচপিএলসি তে কেন করতে পারি না? Answer is, in gas chromatography mobile phase is carrier gas. Carrier gas is a free flowing substance. It can flow certain distance within a very lesser time. But case of HPLC, we are using pump to flow the liquid mobile phase in or through the column. So you can assume if we are increasing the length of the column, how much high capacity pump we may have to use. Ultimately that will increase the cost of separation, and also that may create some other problem. পাম্প আমি আরো হাই লেভেলের পাম্প ইউজ করতে পারি, তাতে কি হবে, কস্ট অনেকটা বেড়ে যাবে। প্লাস অ্যানাদার প্রবলেম, তুমি যতই আমরা যে ট্রাই করি না কেন, আরো হাই ক্যাপাসিটি কালাম ইউজ করতে গেলে ইনস্ট্রুমেন্টের সাইজ বড় হবে। there are so many problem and it is very difficult to create nowadays whatever we are using, the pressure or the flow rate is the optimum. To achieve much more flow rate and pressure is very difficult, so that we cannot so many problems are there, so that we cannot use the, we cannot increase the length of the HPLC column. But this type of problem is not there in gas chromatography. There is no chances or no question of pump. Main reason is that here we are using mobile phase is the gas. Gaseous mobile phase flow can flow freely, so that we can increase the column length. As the column length is much longer than HPLC column, so we can get better separation. That is the main reason. Clear? So definitely the columns we are using in case of gas chromatography will be different from the HPLC column. Nature and the characteristics will be definitely different. Length of the column may, there are mainly two type of columns used in gas chromatography. Majorly two types of columns are there. What are the column? Definitely এখানে বললাম HPLC থেকে তো একটু আলাদা হবে. So first is the packed column and number two is the open tubular column. First we will discuss about the packed column. What is packed column? These are prepared by packing metal or glass tubing with granular stationary phase. So if whenever we are using packed column means they will be packed with some packing material. What are the packing material? Maybe glass tubing or granular stationary phase. But you know, this type of packed column are obsolete, not widely used. So definitely these are lesser used. Okay, and it may create so many problems also. So generally packed column are not widely used. In GSC they are packed with size graded adsorbent or porous polymer. So whenever we are using solid adsorbent or solid stationary phase, we are using generally size graded adsorbent or porous polymer. In case of HPLC column also we have used porous polymer, otherwise they cannot adsorb the material. In case of GLC, liquid are coated with size graded inert solid support. As well as gas solid chromatography, this type of column we can use in GLC also. In that case, that packing material, the size graded inert solid material are coated with inert mobile phase. That means that solid packing material they are coated with liquid, but still this packed column is not ideal either for gas solid chromatography or gas liquid chromatography, because they will create the free flowing of the mobile phase or the carrier gas, and there will be a retention problem, peak tailing, peak fronting, all the problem we discussed. We cannot get good size peak or good shape peak, we may not get. It is not at all convenient. It may take more time also. So packed column are nowadays obsolete. These are the older type of column. Now it is not at all or very rarely used. So what are the modern column or the presently what we are used? Before that, the advantage of the porous polymer are listed below. What are the advantage? These are stable up to the 250 degrees centigrade, no column bleed, allow the use of sensitive detector. So by if we are using, they may have some advantage like this. These are definitely, these are also having some advantage, but we have to judge which advantage is more. That we can discuss ultimately later. এরপরে আমরা discuss করব. Another point, there is no absorption of polar material like water, ethanol, etc. So they eluted rapidly and sharp peak is obtained. These are mechanically strong, can be packed easily on the column. So these are the somewhat advantages in case of packed column. But still they are not more advantageous as compared to open tubular, because major reason is that open tubular are free flowing. Mobile phase can flow very freely, though they are the advantages, but these are not the major advantages. The major advantage of this second type of column is the open tubular column. So let me discuss first this one, open tubular column. So these are also known as capillary or goloic or open tubular. So these having three synonym: open tubular, capillary column, goloic column. Same type of column having three names. Remember, from this point so many multiple choice questions come sometime. So open tubular is also known as capillary. Capillary মানে ভেতরটা খালি, and they are also known as goloic column, made up of long capillary tubing. Length is approximately 30 to 90 meters. They can be very free flowing. Generally, open tubular columns are having much more length. Packed column may not be having much more length because the inside this we cannot use the so much of packing material. Only open tubular column having this much length. That also you remember. If we are using packed column, length of the column will be reduced. So that is also another reason we may not get better result. Open tubular column, we can use the longer column. It has uniform and narrow internal diameter, 0.025 to 0.075 centimeter. Very important. These measurements you try to remember. These are the very important facts. এগুলো থেকে কিন্তু অনেক কোশ্চেন আছে এমসিকিউস। So 0.025 থেকে 0.075 centimeter internal diameter, made up of stainless steel, copper, nylon, glass, etc. Any durable material